This lesson is for section 1.3 on solving equations. We have three main objectives for today. We're going to determine the domain of a variable, we're going to solve literal equations, and we're also going to solve quadratic equations. So today we're going to be brushing up on your advanced algebra skills in hopes that you're really going to lay a very solid foundation for the rest of your pre-calc coursework here, okay? So we want to make sure you're setting yourself up for success. Now, one of the basic things I want to talk about is what you're able to do when you go about solving an equation. Way back when I was in like 5th grade, I remember my teacher telling us that we had to follow the golden rule when we were solving equations. We had to do unto one side of an equation what we would do to the other. So we want to make sure you know what is legal when you're solving an equation. I know these rules seem pretty basic. These are things that you do intuitively a lot, but a lot of you also make mistakes when you're doing this. So you always want to make sure they're adding and subtracting the same quantity on both sides of an equation to produce an equivalent equation. You want to make sure you're always multiplying and dividing both sides by the same exact non-zero quantity, okay, to produce an equivalent equation. You also want to make sure you're simplifying correctly the expressions on both sides of an equation, okay? Now, like I said, it seems really easy to be able to follow these three rules, but a lot of times I see algebraic mistakes all over papers all the way up till, through BC Calc next year. So what I want to do is actually take a look at some common ones in class tomorrow, so you kind of get an idea of what you shouldn't be doing in a problem. Now, with that said, let's take a look at example number 1 here, which is really a topic from advanced algebra last year. So one of the very first things I want you to do whenever you're solving an equation is to really consider the domain of that variable. For example, if I were to get an answer here, like x is equal to -5/2, right away I know that this is not a viable solution, because if I try to plug that back into the original equation here, I end up with 0 in the denominator. So just make sure you're not being a robot when you're solving problems. You really need to think about them as you're going through and trying to find your solution. All right, so the first thing I want to do here is find that least common denominator, which happens to be 4x squared minus 25. Notice these are factors of 4x squared minus 25. So all I have to do to create an equivalent fraction here is to multiply this first fraction by 2x minus 5 over 2x minus 5. So now I have that common denominator here. Oops, that should be a minus 5. So this is 4x squared minus 25, okay? Second fraction, we're going to multiply that one by 2x plus 5 over 2x plus 5. And I'll just rewrite that denominator here as that LCD. Okay, now, once we're here, we know that we can clear out that denominator by multiplying on both sides of the equation here by 4x squared minus 25. So now that's going to cancel out the denominators. Let me rewrite that in here. Make sure that we're always multiplying by the same quantity here on both sides of the equation. So that'll clear out that denominator, and I'm just left with the numerators. I have 2 times 2x minus 5 plus 3 times 2x plus 5 is equal to 10x plus 5. So from here it's pretty much some basic algebra, right? We're just going to distribute and combine like terms. And what happens when we're solving is we end up with this statement 10x plus 5 is equal to 10x plus 5. So really what we end up with is a true statement, right? If we wanted to subtract 10x from both sides and subtract 5, we'd end up with this equivalent statement 0 is equal to 0, or 5 is equal to 5, or 10x is equal to 10x. However you want to do it, you're always going to end up with a true statement. So we have an infinite number of solutions. Now if you wanted to write all reals, remember we can write that with that double bar r like this, except x is not allowed to be, we said -5/2, right? But also x can't be 5/2 as well. If x is 5/2 or -5/2, then we have 0 in the denominator. So this is how you could write your answer. Now I want to kind of go back to interval notation, make sure we know how to write this in interval notation. This would be from -infinity, right? Since we're doing all real numbers, to -5/2. That's an open circle here, or I'm sorry, an open parenthesis there. And then we have to join that with -5/2 to 5/2. So notice that I have 3 different intervals here. So 5/2 to infinity. So let's talk about why that is. If we want to do every single number on a number line except the number -5/2 and 5/2, right, we have to represent that with all this entire interval, the interval between here and this unbounded interval to positive infinity. So this is how we would write that solution in interval notation. Okay, so I'll clean this up and then we'll start working on 2 and 3. All right, now in example 2, we're asked again to find the domain. This time it's not an equation. We're just looking at an expression here. But still the same rules apply. We can't have 0 in the denominator. Okay, so if we factor this, we can see that x cannot equal 3 or negative 3. Okay, now in the numerator and the denominator, both of these are actually polynomials. In the numerator, though, it really makes no difference what that numerator is equal to. It could be 0, right? So we have no restriction on what the numerator can be. So even if we factor this, it really doesn't tell us much because the numerator can be anything. It's just really the denominator we have to focus on. Okay. Now, if we want to write this in interval notation, once again, we're dealing with, if we were to just draw this out on a number line, we've got all real numbers except the two numbers, negative 3 and 3. So in interval notation, we've got an unbounded interval from negative infinity to negative 3, union negative 3 to 3, so we have an open interval here, and then another unbounded interval from 3 to positive infinity. So, all right, so in number 3, once again, let's focus on the denominator here to figure out our domain. We don't really have to pay much attention to our numerator. So considering the denominator, it can't be equal to 0. Let's set it equal to 0 to figure out what x can't equal. I know that most of you can just look at that and say x can't equal 2, but make sure you know how to actually set this up algebraically just in case things get a little bit more complicated and there could be like a quadratic on the inside here. Okay, so this is what we would algebraically do. We'd square both sides and we end up with x is equal to 2. Now, that means x can't equal 2 for the domain, correct? Because that would set it equal to 0. There is also something else to consider. The fact that we have this radical here in the first place, that does change things. If we have a radical, remember, the square root of 4, that's a real number, but the square root of negative 4 is not. We have to have real numbers in our domain. So what we're going to do is make sure that 2 minus x is always positive. Okay, 2 minus x needs to always be positive in order for us to be able to take the square root. So if we solve this inequality here, we have to make sure that we switch the sign here. We have to flip that sign, and we know x is less than 2. So we have all real numbers less than 2. X cannot equal 2. It must be less than 2. So on a number line, obviously, if you want to draw it like that, you can. You can do it with our interval notation as well. But as an interval, it would be just from negative infinity to 2. All right, next up, we're going to solve literal equations, which I found is very difficult for students early on in the semester. You get really confused when you have more than one variable. But basically, all we're going to do is follow the exact same steps that we'd take in a normal equation. So make sure that if you're having trouble, substitute some numbers into there and see if what you're doing is actually a legal operation, okay? All right, so we're going to solve for a in this first example here. Amongst all of these variables here, we want to try to solve for a alone, which means when you solve for a, you shouldn't see a here on the other side. This is a big no-no, okay? When it asks you to solve for a, that means isolate a, get a up completely by itself, okay? So first, let's talk about these steps here that I have written to the side. You always want to eliminate your intended variable. In this case, our intended variable is a from the denominator. Well, here we don't have a denominator, so we can kind of skip that step. Step 2 says get all intended variables to one side. So right now I see that I have an a on one side and on the other. So I definitely have to make sure that at some point I collect those variables together, okay? You will always be factoring, most likely, in all of the problems that we're going to be doing, and then dividing would be your final step, usually, okay? So let's begin with number 4 here. One thing you don't want to do is try to add ay to both sides right away, okay? This would be a very illegal operation because really, xay is the product, not just ay. That x here, once we distribute it, actually belongs with ay. So you can't just skip steps like that, okay? So what we're going to do first is just distribute. So we have xc minus axy is equal to ae plus f. So my next step here is to try to get the variables to one side. So it really makes no difference how you choose to do it. I would probably move this to the right-hand side just so it becomes positive, and I can move that f to the other. Okay, so I'm going to add axy here, and I'm going to subtract f to the other side. All right, now at this point, definitely this is the step we have to take. We have to factor out this variable. We want to get it by itself somehow, so we're going to factor that out. Okay, and we're really close now to having a completely on its own. Once we have this variable, our intended variable, factored out, now we can simply divide by e plus xy on both sides here of this equation. and that results in having a alone. So we have a is equal to xc minus f over e plus xy. Okay, so this would be my final answer for number 4. All right, so in problem 5, you see that we have our intended variable, b, here in the denominator, so we need to make sure we get that out of the denominator right away. We'll multiply by a plus b on both sides. Now, once we do that, we can go ahead and distribute here on the left-hand side. And then we definitely want to make sure we collect all of our intended variables to one side. We want to make sure we get b's all together. So I'm just going to subtract that ab here. So I have a squared is equal to b minus ab. And then we're going to factor. So now it starts to really pick up in the same kind of similar pattern. Obviously, every problem will vary with difficulty, but you can follow pretty similar patterns. So you have a squared is equal to b times 1 minus a. And now once we've factored out that b and b can be by itself, we can divide out that 1 minus a. Okay, so we have a squared over 1 minus a is equal to b. All right, so we're kind of working our way up to problem number 6 now. This one's a little bit more difficult than 4 and 5, and I actually want you to try this one on your own. Go ahead and check the key. Make sure you look at the detailed solution in case you don't get the correct answer here, okay? So we'll move on now to the back side of your notes. All right, so to continue on with our advanced algebra review, we're going to be solving quadratic equations. Now, there are 4 different methods that you learned back in 90s algebra, and we're going to review them all briefly today. Your favorite one was probably square roots, just because that's the fastest method to use. The problem with this is that it doesn't always work. Like, for example, problem 7, 8, and 9, you can't use the square root method at all, including 11 as well. Okay, now factoring is my favorite. Not all students like it, but I like to factor. Number 3, this quadratic formula one, this is one I see a lot of students rely on, although you shouldn't be using your calculator for it, so make sure, I know a lot of you have the quad program, but don't use it on your homework because you will have a non-calc quiz and test. So you need to know how to do the quadratic formula by hand, but don't rely on it because it's a lot easier to make mistakes using that method. And finally, completing the square. This is also one of my favorites. We're actually going to do a proof of the quadratic formula by completing the square. So we'll come to that in a second. So first up, let's talk about just factoring. Here we've got a basic factoring problem with a lead coefficient that is not 1. So make sure you're always getting 0 on one side of the equation first, and then continuing to solve. Some of you rely on a guess and check method, others maybe split the middle term. I'm going to just guess and check on this one, but you need to find 2 numbers that will multiply to negative 10, and the lead coefficient here has to be 3, so there's really only the option of having 3x and x here. Since I'm trying to get to 10, I'm going to use 5 and 2. Let's see, if I put a 2 here, I end up with 6x, and if I put the 5 here, that's 5x, so that doesn't give me 13, so let's try this 3x minus 2 and x plus 5. Let's double check that that works. Yes, it does. Okay, so now that I have my factors, I'm going to set each of these equal to 0. So I have x is equal to 2/3 and x is equal to negative 5. All right, as we look at number 8 here, the major idea is that you have to make sure you multiply before you even try to factor here. So we would subtract that 182 to the other side. And then we're looking for 2 numbers that multiply to negative 182 and add up to positive 1. Since this ends in a 2, that kind of narrows it down for you. You're looking for two two-digit numbers that will end in 2 when you multiply them. So 14 and 13 would work here. Okay, so we've got x squared plus 14 and x, oh geez, what am I saying? Sorry, x plus 14 and x minus 13 equals 0. So use the 0 product property and you end up with x is equal to negative 14 and x is equal to 13. All right, now moving on to our last factoring problem. I know this looks like it's not factorable at first, but in fact, the numbers that will multiply to 7 and add up to 2 root 7, well, that's just root 7, right? Root 7 times itself is 7, and root 7 plus root 7 is 2 root 7. So those are the numbers that we're going to use. This ends up being a perfect square. This is x plus root 7 times x plus root 7. This is why I called it a perfect square. So you can just call that x plus root 7, the quantity, squared. So we end up with the solution x is equal to negative root 7. All right, now in number 10, this one, like I said, is probably your favorite method just because it's the quickest. You're going to isolate your variable when you want to use the square root method here. by adding 72 on both sides. Let's take the square root now of both sides. And just recall that when you take that square root of the right-hand side, this is positive or negative root 72. We will also have to reduce this radical. So the largest perfect square that fits inside there is 36. So that's going to reduce to 6 root 2. Okay, so we have x plus 2 is equal to positive or negative 6 root 2. We're going to subtract now the negative 2 here. So we'll have x is equal to negative 2 plus or minus 6 root 2. So there's my final answer here. So basically the reason why I wanted to cover this is to make sure you remember to reduce radicals, but also this is a crucial step. A lot of times students forget the positive negative, okay? Finally, we have problem 11 here with the quadratic formula. I'm going to write out the quadratic formula for you. Remember, you're not going to be able to use a calculator, so you do need to know how to use the quadratic formula by hand. You're also going to be simplifying it completely as well. So we have two solutions here. X is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. And that's when we have a quadratic of this form. Okay, so first we need to make sure that this quadratic is in the correct form. So we're going to add root 2x. And I would like you guys to go ahead and use the quadratic formula here. Just practice doing that on your own individually and then go ahead and check with the key, okay? Please make sure you're trying this because you shouldn't try it for the first time on a quiz or a test, okay? So let's go ahead and move on now to deriving the quadratic formula by our method of completing the square. All right, so hopefully you do remember how to complete the square, but just in case you have to jog your memory here, I do have the steps written out to the side. We're going to work on this first problem together, and then we're going to actually take this quadratic and complete the square here with just variables. So we're kind of tying in that whole literal equation skill that we were just working on the front side of your notes. So let's go ahead and get started. Our first step is to move this constant here to the other side. On the directions here it says to move it with the side with y, and that's just if this happens to be a function, okay, if that was equal to y. Now I think I'm going to change this slightly, make that a negative 3 here, okay? So we're going to add 3 to the other side, so we end up with 2x squared minus 4x is equal to 3. Now at this point, the next step here is really important. You need to make sure you factor out only the lead coefficient here. The quadratic coefficient has to be factored out. Do not take out the GCF here, which would be 2x. Don't do that because then you'll be really confused. You just want to take out that lead coefficient. So I have 2 times x squared minus 2x. I'm going to leave a little bit of space for myself. And the right on the other side is equal to 3. Now here's where we complete the square. We want to turn this expression here into a perfect square. So what I'm going to do is I cut this number here, this linear term, the negative 2, I cut that in half. So I end up with negative 1, and then I take that negative 1 and I square that value. So the number I always put here should always be positive because I'm always squaring a value. So remember, this sign should never be negative, okay? Now, I just added not just 1, but I actually added 2 times 1, right, to this left-hand side. I always have to make sure I balance my equation. This is so important. Students forget to balance a lot. Please make sure you would add 2 to the other side. So you always multiply here. That's what you're adding on the left-hand side. Make sure you balance it out on the right. So now we have 2 times. And then what I'm going to do here is factor this so I have a nice looking perfect square. So if I factor here, I end up with x minus 1 squared. So that's kind of nice here. It just turns into that nice perfect square so that I can take this and now use the square root method when I want to solve. So go ahead now and divide by 2 and take the square root of both sides. Make sure you write out in front here positive or negative. It's really important. And then add 1. So we have 1 plus or minus the square root of 5/2. All right. All right, so finally we get to the hardest part of the lesson. Now this is something that we're going to practice a lot throughout the chapter. You'll see it on a quiz. It's not the exact same problem, but you'll see it on the quiz, and you'll see another problem similar to that on the test. So we need to make sure you really understand this process. It's not something you can memorize because we're going to change up each problem just slightly. So it really is a process where you have to understand how to complete the square, okay? Now we're going to start with this general equation for a quadratic here. It's got all these variables in it, so we're kind of combining the whole literal equation thing here. And we want to follow the same steps. So remember, that first step is just to subtract c on both sides, this constant. We want to get rid of that constant, okay? So we have ax squared plus bx is equal to negative c. Our second step, remember, was to factor out only the lead coefficient. So we want to factor out that a. When I factor out that a, I'm going to write this middle term, that linear term, as b over ax. Okay, so I just factored out an a from bx. Now, at this point, this is kind of where it's a little trickier for students because the first two steps seem pretty simple. Now, this step here, this is where you're actually going to complete the square. So you're going to take that and cut it in half. Remember, take the linear term and cut it in half. When we cut that in half, that's b over 2a. Okay? Now, we take this quantity, remember, and then we square it. So we're going to square b over 2a, and we get b squared over 4a squared. Again, if you're not quite sure why we're doing that, remember if we go back to our original problem over here, we took this number, -2, we cut it in half, we got -1, and then we squared it. Okay? So that's what we're going to do as well. Now, we add this inside that parentheses here. Let me change color so you can see it a little easier. Okay, the thing is, you always have to remember this crucial step. A lot of times students will forget this. You have to balance your equation. So what are we going to add to the other side? Well, think about it. We're not just going to add b squared over 4a squared because we're multiplying it by another a, right? So really what we're adding now is b squared over 4a. All right, now this is another tricky part. Here comes the factoring. We need to factor this to get that perfect square. So a lot of times students freak out at this point because they don't know how to quite factor this, but don't worry, you do, because think back to where we were over here. Look at the correlation between how we wrote, let me uncircle that, this factor here is x minus 1. This 1, -1, came from that number that we squared. That's always going to be the case. You will always, when you factor it, you'll always get that original number that you originally had squared. So what was that quantity that we squared? It was b over 2a. So this is going to factor nicely into x plus b over 2a. If you're really unconvinced, you're not quite sure if that's correct, you can always multiply that back out and you should get this, right? So you can always double check in case you're worried. Now on the other side we have -c plus b squared over 4a. Okay. Now, we're close. We want to get x alone, right? Our goal is to completely solve for x. So we need to get rid of that a first, and then we can go ahead and square root. So I want to first get a common denominator here so I can put these together. So I'm going to multiply by 4a over 4a here so I have a common denominator there. So I have -4ac over 4a. Hopefully you just followed that step. Rewind it, pause it if you didn't quite follow. And now I can combine these together. So I have b squared minus 4ac here, all over 4a. That's the right-hand side. I still have this a here, though. So now I'm going to divide out that a to the other side. Let's see. Let's keep that the same. We're going to divide that out. So now I have a squared, okay, in the denominator. Once I divide that a to the other side, it becomes 4a squared in the denominator. All right, hopefully you're still following me. And like I said, we're going to get a lot of practice with this, okay? Now we're going to square root both sides of this equation. So we have x plus b over 2a is equal to, on the right-hand side, plus or minus the square root of b squared minus 4ac all over 4a squared. Now, this might start looking a little familiar to you. If not, that's okay. On the right-hand side, let's try to simplify this. We have plus or minus the square root. In the numerator here, I can't really do anything. It's not a perfect square, so I can't really simplify that. But in the denominator, the square root of 4a squared, well, that's just 2a. So it's outside of the radical now. I can drop that radical. So I have x plus b over 2a is equal to, positive or negative, square root of b squared minus 4ac all over 2a. Now I want x completely alone. So my last step here is to get rid of this b over 2a. So I will subtract it. So I have negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. Now, take a look at this. We can rewrite that as x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And you have just derived the quadratic formula. I know you're probably not very excited about it, but you should be. It's your first time doing it. It's awesome. Okay, so you're going to get lots of practice with it. You can ask lots of questions tomorrow. Pause, rewind, replay however many times you need to kind of make sure this is a little bit more fluid, and we'll talk and discuss about this tomorrow in class. All right, great job, guys. I will see you tomorrow.